Hi everyone, this is the second half of section 1.9 and we're going to be talking about circles. So notice there's a definition. The idea of a circle is that you have a point in the middle and the circle is the every other point that is the same distance from that center point. So the circle itself is the set of points that are all around. The center is not a point on the circle. The fixed point, however, is called the center. It's not a point on the circle, but it's called the center. The constant distance, many of you know, once I say it probably, is the radius. So that is the same radius is all around that fixed point, the center. So we've talked already about the distance formula, and actually, if you think about it, that's where the formula for a circle comes from. So the idea is the center of a circle, let's put it right here. You can see that that is the center of this circle. We're going to call the center H comma K. That's a point. That is actually typically what the center is called. And we have, say, some point out here, X, Y. And as we know, the radius here is the distance from the center out to any point. So that xy is arbitrary. It could be anywhere. I just happen to put it on that side of the circle. But if you think about it, what we know from the distance formula is that that distance, that radius, is the square root of the difference between two things. And that's going to be x minus h, those are the two first values of each point, squared, plus, and then y minus k squared. And then you are probably not surprised maybe to find out that if we then square both sides, you're going to find that we get, gotta find myself here, where am I? There we are, r squared equals, and then that just takes the square root off the other side. And so what we have is now the equation of a circle. So you will see, I'll write it down here again, but I'm literally just going to write the same thing. So you can also just do an arrow. So the equation of a circle is that, and actually maybe I will write it slightly differently just by moving the sides. It is not uncommon at all to see the equation of a circle as starting with x minus h squared plus y minus k squared equals r squared. So all you need to really remember here is that x and y stay in this equation. They're always going to be there. H and k change depending on what the center is. And then r is the radius. So let's take a look. All right, so pretty straightforward first example. We want the equation of a circle that has center 3 comma negative 2, radius 5. So what I'm kind of saying already is that you know you're going to have this. Looks a little bit weird there, but this is the idea. So all you have to do is fill in my spaces here. So we're going to have x minus 3, because 3 is the x value of our center, y minus k, so that's going to be y minus a negative 2, which is a plus 2. And then we're going to have our radius, which is 5, and that's going to be squared. So this is the equation of that circle. That's it. And I'll write it all in red here, but we have it already there. You already have it. Don't need to write it again if you don't want to. Yep. Now we're being given the equation of a circle, and our job is to find out what is the center and what is the radius, and then graph it. So the key thing probably to see is, because of the form, maybe I'll write it down here. Because of the form of a circle, you want to remember to look at the first piece as x minus a negative 1 squared, plus, you don't have to write this, but do understand that y squared is the same as y minus 0 squared, if you're thinking about what that y value is going to be. And then remember that 6 is r squared. So what that means is, really, you can rewrite that as the square root of 6 squared. And that's because that is 6. So this radius does not have a perfect square radius, or this radius is not a perfect square. But writing it like this helps us because it tells us that the center is -1, 0, the x and the y, coming of course from here and here. And then the radius is the square root of 6. And for us, that is about 2.4. Graphing a circle, if you have the center and the radius, graphing a circle is not too bad. I have a tablet, so it could be worse than for me, but here we go. So the first thing to do is just to put on your center. So -1, 0, boom, there's our center. And then all we really need to do is go about 2.4 units away from that center in the, up, down, left, and right. So about 2.4 up is maybe about here. Then we're going to have 2.4 down, maybe about here, 2.4, and maybe a 2.4 over here. And then you really just need to connect those points. And that's why I kind of, and my points are gone. Okay. So there we go. Okay. So now you just need to connect them in the best way that you can, which is, the hardest thing for me to do with my tablet. But that's the idea. Oh, I think I have my wrong. Oops. This one is too far out. I see what I did. So 2.4 from the center. So I should be, that was that point right there. Okay, I got it. All right, so now I'm just gonna try to make it like a circle. But if I do it in 4 pieces, it will not be pretty. But I'm gonna try. That's the best I can do, and it's not really a circle. So do the best you can. You are not being, checked for perfect circle, but you do try to do the best you can here, just to make it circular. But that's all you have to do. Now you have your graph of your circle. All right, so a little more with circles is that you might actually see a circle that is in general form instead of the form that we saw on the first part there, which is standard form. So this is general form. What we saw before is standard form. So our job here, because when you look at the equation of a circle in a standard form, you're like, boom, circle, boom, radius. You know all this stuff about the circle. When you look at a circle in this form, you're like, this is a circle? That might be your first question. And then you're thinking, well, I don't see the center and I don't see the radius, but you can, you can get there. So our job is to take what you see there, write it in standard form. So here's how we do that. Stop me if at any point you're with me and you want to do it yourself. What I'm going to start with is I'm going to take my variables and I'm going to put them together. So I have an x squared and a minus 2x. Then, because I know what's going to happen, I'm going to put a plus with a space. Then I'm going to do my y's. And then I'm going to put a space. Then I'm going to have equals, and I'm going to put my constant on the other side. Now there is a reason that I am going to do this, and that is because the thing that we need to do to write this into standard form, if you remember what standard form looks like, it wasn't that long ago, is that you need to have something squared. You have this binomial squared, unless the center has a 0 portion, and then you don't have a binomial, but that's what we're going to have here. So what we need to do here is we need to complete the square twice. So our job is now to find the constants that go in these 2 blank spaces that I've created here that complete the square for the first 2 terms that you see. So we've done a little bit of completing the square before. Remember that the idea is if you have a quadratic idea, so the idea of a squared plus bx plus c, to complete a square, you need to take half of your linear term. So in our case, half of our linear term is -1, and then we square it. And that means that we need to add 1 here. I'm going to do that to the other side because we have an equation here. We have an equal sign, so we've got to do it to the other side as well. It keeps everything balanced. I'm going to do the same thing with my variable y. I'm going to take half of 6, because that's the coefficient for the linear term, and then I'm going to square it. And that tells me that my perfect square, I need a 9. So I'm going to bring that to adding that to both sides. Now, the idea is I can now rewrite this as a binomial squared plus a binomial squared equals, and then that constant. So I have a -1 plus 1 plus 9. So I'm going to have 9, because -1 plus 1 is 0. Then I need to factor this. So notice we talked about factoring. It's coming back. This stuff all relates to each other. We see all this coming back again. So remember that the term that goes inside, the number that goes inside is what you get when you do half the middle term. So I need an x minus 1. For the second piece, I need a y plus 3. Notice now we have it in standard form. You could, if you wanted to, x minus 1 squared, y plus 3 squared equals, and you don't want to forget, 9 is 3 squared. So you have all the pieces that you need. See if you can write out what you think the center is. You can write out what the radius is as well. If you want to try to graph it first, that would be great. See what you get. Okay, now that is not bad, everyone. I am impressed with myself. Okay, so our center here is 1, -3, and our radius is 3. So I'm going to put that center on, and then I'm going to go 3 up, 3 down, 3 left, 3 right, and then I'm going to connect them, and then I have my circle. Okay, now, just a little bit more than what we just did. We're not going to graph this one, but we have the equation of a circle in standard form. That's our job, is to write it in standard form. This is not in standard form. Can you see a big difference between this one and the one we just did? Can you see a big difference? You may notice that this one has values in front of the x squared and the y squared. Now, unfortunately, there's not a lot you can do with those numbers in front of the x squared and the y squared, because we want to complete the square and we want to put it in standard form, so we want x minus something squared, y minus something squared. Having a coefficient in front of the x squared and the y squared causes a problem. So what we do is we get rid of it. So we don't just trash it. You actually have to take, and a couple different ways you can think about it is, but we're going to divide both sides basically by 3 here. We're going to divide both sides by 3, and that simply means dividing each and every piece of both sides by 3. So it works out real nice for the first 2. We're simplifying the 3. We can do it again with the 6x over 3, the 12y over 3. That's nice too. We do end up with the last term being a fraction. Don't forget it. You can't just decide you're not going to divide it by 3 just because it's not pretty. You got to divide it by 3. But now it gives us something a little more like what we just had. So if you want, you can take a moment, see if you can move your variables together, see if you can complete your square, add whatever you're adding to the left side, to the right side, see what happens. So I would recommend pausing and doing that. So I'm separating. I'm going to bring that constant to the other side. Now I've got to complete my square. I'm going to take half of 2, which is 1. I'm going to square it, 1. Bring that over here as well. I'm going to take half of 4, that's 2. Square it, 4. It's going to look like this. So now my sides are still balanced. Now I'm going to factor, and I'm going to factor. And then on this side, I'm going to add. So let's factor first. So half of 2 is 1. So that's the value I want here. Half of 4 is 2. So that's the value I want here. Okay. Now I need to take negative 20 over 3 and add 5. 5 is 15 over 3. So that's going to give me a negative 5 over 3. All right, now comes the whole reason that we did this, which is, so we have this great left-hand side. We're like, oh yeah, center of this circle. We've got negative 1, negative 2. That's the center. Radius, oh wait. The radius here is negative, or the number here is negative, I should say. Therefore, what you need to understand is on the right-hand side should be r squared. And r squared should always be positive because it's something squared. So when you get a negative, or if you have a negative, this in fact is not a circle. Not a circle. So just something to know. If you have your radius squared being negative, well, then it's not a radius squared. It's not a radius at all. R squared cannot equal a negative. Okay. So just know that. That's just to understand that. I know I tricked you. I apologize. Do note, however, because now we know if it's positive, you got a circle. If it's negative, you do not. But you could have this, if you were, I'm just saying, if you did end up with it equaling 0, you might be like, what is that? So this is a point. So this is literally, I want you to realize that there's only one value of x and y that would make the left side equal 0. And that's a negative 1, negative 2. That's the only point where you can put it in and get 0 on the right side. So because of that, not surprisingly, we end up with just 1 point as the answer to that. So, nothing too exciting. Okay. Last thing here, last thing. We have the points that are the endpoints of the diameter of a circle. So something to remember is that diameter is 2 times the radius. So 2 radii make the diameter. Find the standard form for the equation of a circle. So notice, we are not given the radius and we are not given the center, but we are being expected to find it by being given some points. So I'm going to put my points on 6, -3. Let me find 6, -3 here. Let me find 2, 5. I'm going to come up here. So we know that those 2 points are on the circle, and more importantly, they are the endpoints of the diameter of a circle, which means that those 2 points, if you go from one point to another point across the circle, you have to go through the radius. And because we know that the radius is an equal distance to any of the points out on the outside of the circle, this means that the midpoint of those points will be the radius. Well, it'll be the center, and that will allow us to find the radius. Okay, so first thing we want to do, let's do some steps here, make it straightforward here. So we need the midpoint, because the midpoint is the center. So remember midpoint from earlier, we just find the average of the x values of the 2 points on the circle, and I'll erase that midpoint of the y values by finding the average. Okay, so like this. So that tells us that our center is 4, 1. Notice, let's see, that's not too surprising. Like if you think about that, yeah, that looks about halfway. So that makes sense. So that's our center. So that's great, we're halfway there. And then we still need the radius. But remember, the radius is just a distance from any point to the outside of the circle. So you can just pick any point. You need 2. So you need the midpoint, which is the center, and either of the other 2 points. It does not matter. It'll give you the same thing, I promise. So we will take, let's pick the point where everything is positive. That's nice. All right, so we're going to go 2 minus 4 squared, and then 5 minus 1 squared. So again, I'm using the center as well as one of the either 2 points to find what the distance of the radius is. So that's going to give me, it looks like, negative 2 squared, which is 4, and then 4 squared, which is 16. So we get the square root of 20 as our radius. You could simplify this if you wanted to. Because of the standard form, it's not really necessary, but it does have a perfect square in it. It's 4 times 5, so 2 root 5 if you simplify it. Okay, but now we're just going to write our standard form here. So remember, standard form of a circle, standard form of a circle is, thank you, x minus h in this case. Remember, x minus the center, right? The x value of the center, so we need x minus 4 squared. And then we need, you can go ahead and can finish this if you want, y minus and then our y value here. And then that needs to equal r squared. So that's just the square root of 20 squared. So that's 20. So we can just write it as 20. And then that writes the circle in standard form. So that is section 1.9.